Okay, so now let's solve the same problem using the shortcut method and see how we can solve the problem that way. And I'm not very much familiar with the shortcut method. Let's see how we can solve the problem. So we said that using the shortcut method, we said that y of I is equal to basically x of I minus a over h, right? So that means that it's the same thing as, it is the same thing as this x of I minus a is the same thing as d of I, because d of I is the same thing as basically x of I minus a. So if I take this as capital A, now, and take this as capital A, then basically all of this calculation is already we have done. And then if I divide that by h, divide this by h, what I will get is basically so then y of I would be basically this column, whatever we have here, divided by the class size, which is basically 30. So that's negative 3, for example. That's negative 2. That's negative 1. That is 0. That is 1. That is 2. And that is a 3. And then we said that sigma squared of x, and then we said that basically sigma squared of x, sigma of x squared is equal to h over n. If I'm not mistaken, I'll try to not make any mistakes. H over n times the square root of n times sigma, what was it? N times sigma, no, not this one. This is the standard deviation. Okay. H over n times the square root of n times sigma f of I, for example, y of I squared, as I goes from 1 to n, minus sigma f of I times y of I as I goes from 1 to n, and this is squared. So now what I need to calculate is also f of I times y of I squared. I need to calculate this one as well. So f of I times y of I squared. So y of I squared is equal to, for example, 9 times 2 is equal to 18. 4 times 3 is equal to 12. 1 times 5 is equal to 5. That's a 0. 1 times 3 is equal to 3. 4 times 5 is equal to 20. And 9 times 2 is equal to 18. And then over here I can calculate sigma f of y y of I squared as I goes from 1 to n, which is equal to all of these numbers added together. That's it. Basically 20, 30, 35, 38, 58, 68 plus 8 is equal to 16, 76. That's 76. And then you have to multiply n by that, which is okay. And f of I, y of I would be I have to calculate that as well, f of I, y of I. So that is equal to 2 times, that's negative 6. That is 3 times negative 2, which is equal to negative 6. That is 5 times negative 1 is negative 5. That's a 0. That's 1 times 3 is equal to 3. 2 times 5 is equal to 10. 3 times 2 is equal to 6. And sigma f of I, y of I, as I goes from 1 to n, is equal to basically that's 12, 17, that's negative 17, and over here you have positive 19, so let's say 19 minus 7 is equal to 2. That is equal to 2. So now everything is ready for this formula. So now what I can do is basically, I know that my h is, the class size is 30. Sigma of x whole squared is equal to 30, and my n is equal to 30 as well, times the square root of n is equal to 30. Now sigma f of I, y of I squared is equal to 76 times 76 minus basically sigma f of I, y of I squared. 2 times 2 squared is equal to 4. And that is equal to, well, this is equal to 1. And 76 times 3 is equal to 18, 1, 21, 22, that's 2280. 2280 minus 4 is equal to 2276, is equal to the square root of 2276, which you can calculate. It seems that this is actually easier compared to all the basically calculation that we did over there. All of these basically complicated numbers, this is much easier because your numbers will get much smaller, as you can see here, and then it's very easy to work with these numbers. Now again, to take the square root of 2276, we can basically work a little bit with, let me first calculate it using the calculator, and then square root of 2276 is equal to 47.7. 47.7. I don't know what the answer was previously. What was that? This is 182. That's number 7. Well, there is something wrong here. $22.76, that's correct. But that is actually sigma of x squared. Now over here what we are required to calculate is, I see, the frequency distribution, mean and frequency, and variance. Variance is sigma squared, of course. Oh, I see the problem here. Actually, the formula that I wrote over here, this formula is not actually right. This is supposed to be this way, and this is actually standard deviation. This is actually standard deviation. Now, if you want to use, basically calculate basically variance from this formula, you have to raise this to the second power, meaning that you have to write sigma of x squared, which would be the square root of 2276 whole squared, which would be equal to 2276. Which would be equal to 2276, which is actually the right answer. So the formula actually does work for you, and it's actually easier than all of the formulas that we had before. For example, the formula that we had for variance was basically for example, this formula here, what we had before was, let me show you this formula. So the formula that we had for variance was, for example, sigma squared is equal to, for example, 1 over n sigma of x of I minus x bar, and there is basically an f of I over here as well, squared, as I goes from 1 to n. That is variance. And if you take the square root of this thing, meaning that if you take the square root of this thing, that becomes standard deviation, meaning that you can write sigma is equal to the square root of 1 over n sigma of f of I times x of I minus x bar whole squared, as I goes from 1 to n. And that becomes basically, that is now called standard deviation. Standard deviation. And then we had the shortcut method, which was basically for standard deviation. We got a formula which was sigma is equal to basically h over n times the square root of n times sigma f of I y of I squared, as I goes from 1 to n, minus sigma of f of I y of I, as I goes from 1 to n whole squared, and then you take the square root of this whole expression, and that is standard deviation. Standard deviation, which is basically the shortcut method as we talked about it. The shortcut method. So basically now the conclusion that we came to is that, well, using this formula is much easier than using, for example, the formula for standard deviation, which you would get, for example, this way, or using the same. Basically, these two are the same formulas. But using this seems to be much easier in the case of the kind of data that is large numbers and that sort of thing. Okay, so now the next thing that we have is another example. Example number 8. which is you want to find again the mean and the variance. The mean and variance for this data. So the data that you have is something like this. You have these classes and these frequencies. And you have 0 to 10, 10 to 20, 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. And the frequencies are 5, 8, 15, 16, and 6. So you want to calculate mean and standard deviation. So let's see what sort of, now in order to find the mean of this data, so the standard deviation is, you can use this formula as, for example, sigma, you can use this formula as sigma is equal to, for example, you can always basically, just not to confuse yourself, you can always start with variance, and then, I mean, as long as you want to use the normal formulas, not the shortcut method, you can always use with the variance and then take the square root of variance, because variance is sigma squared. That is variance. And then if you take the square root of sigma squared, you will get sigma, which is basically standard deviation. Standard deviation. Standard deviation. So what you can do is that you can always start with variance, as long as you want to use basically, as long as you don't want to use the shortcut formula. And then once you have your variance, you can take the square root of that, and then that gives you the standard deviation. Now, what we need to do here is, first we need to take a look at the data, see if the data is going to be, needs to be treated or not. If not, then we can use the normal formulas. So I use the class marks here. I calculate the class marks here as, and that would be basically my x of i's. So the average of the lower limits and the upper limits of these classes would be 5, 15, 25, 35, and 45. And you don't really need to do much about these. I mean, it's easy to deal with these numbers. So you can simply find, for example, the mean of the data. For example, you can use it as x bar is equal to, for example, sigma f of I, x of I divided by sigma f of I, and you can use, for example, f of I times x of I here. So for example, 5 times I is equal to 25, 8 times 15 is equal to 80, 120, for example. 15 times 25 is equal to 5 times I is equal to 25, 5, 7, 0, 30, and then you have 5, 7, 3, 3, 7, 5. 16 times 35 is equal to 33. 5, 8, 0, 18, 1, and 4, 0, 16, 16, and 560. And then you have 6 times 45 is 240, and 30, 270. And sigma f of I sigma f of I times x of I is equal to basically 165, 375, 560, 270. And you have the 0 over here, 1, 14, 14 plus 13 is equal to 27, 2, 3, 6, 6 plus 5 is equal to 11, 11 plus 2 is equal to 13, 13, 7. And you have basically 1370 divided by sigma f of I, which is sigma f of I is equal to 13 plus 15 is equal to 28. 28 plus 22 is equal to 40 and 50. So you divide this by 50, you'll get your answer. So now if I divide this, cancel these two out, 137 divided by 5 is not divisible really. But you can write 137 divided by 5. 2 times 5 is equal to 10, 37. 7 times 5 is equal to 35, 2. Zero and 0.4, 27.4 is equal to 27.4. So your basically the mean of the data is 27.4. So x bar is equal to 27.4. Let me see if that is correct, and then we can move forward with the rest. Number 8, 27. Taking it as 27. I'm not sure. Maybe they have rounded the answer or whatever they have done. Let me see. So if I have 8 times 15 is equal to 120. 15 times 25 is equal to 375. 16 times 35 is equal to 560. 6 times 45 is equal to 270. Now 270 plus 560 plus 375 plus 120 plus 25 is equal to 1350. 13, oh, that's 1350. Okay, that's supposed to be 1350. 1350. And then if I divide 1350 by 50, I'll get these two. I can cancel out, and 135 divided by 5 is equal to 2 times 5 is equal to 10, 35 and 7, that's 27. That is 27. I made a mistake there. Okay. Okay, so now we can move forward to calculate the basically the variance for this data. The variance for this data. Okay. So the variance for this data, we said that the variance is sigma squared, and that's equal to basically the formula for variance is 1 over n. It's basically sigma f of I times x of I minus x bar whole squared divided by sigma f of I. Right, that's variance. And then since this is equal to n, then they write this as 1 over n, for example, times sigma of f of I times x of I minus x bar whole squared, as I goes from 1 to n, for example. So but it's basically it is basically the average of basically all of the average of basically this difference over here, raised to the second power, of course. So then using this formula, what you can do is that you need to calculate your x bar. We have already calculated. Now x sub I minus x bar whole squared, x sub I minus x bar whole squared is equal to basically 5 minus 27 is equal to 22 or negative 22. So 5 minus 27 5 minus 27 is equal to negative 22, and negative 22 squared is equal to and again we get into the trouble of calculation, so it's not a good idea really to do this. I think we are better off using the shortcut method. So the shortcut method is sigma, it gives you standard variation, or sigma, which is basically h over n times the square root of n times sigma f of I y of I squared as I goes from 1 to n minus sigma f of I y of I as I goes from 1 to n whole squared. This is I whole squared. Take the square root of this whole thing, and that's standard deviation. So once you calculate standard deviation, when you raise it to the second power, that will be basically variance, which is what you want to calculate here. So what that means is that we have to calculate the things that we have in this formula, and that would be much easier to calculate. So what you want to do is basically, you already know your h, the class size, you know your n, which is sigma f of I is equal to n, and you need to calculate your y of I. Now y of I, we said that it's equal to basically x of I minus a divided by h. So over here I calculate y of I, which is x of I minus a divided by h. So what that means is that, first of all, your h is equal to 30, 40, so your h is equal to 10. 10 minus 0, 20 minus 10, 30 minus 20 is equal to 10. So x of I minus a is basically this column minus a, which is the assumed mean of your data. For example, I take this as the assumed mean of the data. 5 minus 25, for example, divided by 10, which is equal to, for example, negative 20 divided by 10, which is equal to negative 2. That would be negative 2. Again, over here, 15 minus 25 divided by 10, which is equal to, well, negative 10 divided by 10. 25 minus 15 is equal to 0 and 1. Negative 10 divided by 1, negative 1. That's a negative 1. Over here you have 25 minus 25 divided by 10, which is equal to 0. 35 minus 25 is equal to 10 divided by 10 is equal to 1. 45 minus 25 is equal to 20. 20 divided by 10 is equal to 2. So that is your y of I. Once you have your y of I, you want to calculate f of I times y of I squared. F of I times y of I squared. And that is equal to y of I squared times f of I. So 4 times 5 is equal to 20. 1 times 8 is equal to 8. 0. 1 times 16 is equal to 16. 4 times 6 is equal to 24. And so sigma, this part over here, sigma f of I y of I squared is equal to, well, 28 plus this is a 28, and this is over here you have 30 and 40, that's 68. That is 68. And then over here you have sigma f of I y of I. So f of I y of I, that is equal to f of I y of I. So 5 times negative 2 is equal to negative 10. 8 times negative 1 is equal to negative 8. 15 times 0 is equal to 0. 16 times 1 is equal to 16. It's much easier to calculate using this method. And 6 times 2 is equal to 12. And sigma f of I y of I, f of I y of I is equal to negative 18. Negative 18, and over here you have 28. So 28 minus 18 is equal to 10. Is equal to 10. And so sigma f of y of I is equal to 10. So now I can use this formula. Sigma is equal to h, which is equal to 10, divided by n, which is equal to 50, times the square root of n, which is again 50, times sigma f of I y of I squared. F of I y of I squared is equal to 68. Minus basically sigma f of I y of I. 10 squared is equal to 100, which is equal to 10 by 50 is 1 to 5, times the square root of 50 times 68 is equal to 68 times 5 is equal to 44. 4 and 30, 34, 340. 340, no, I'm sorry. 5 times 68, so 5 times 8 is equal to 44. 5 times 6 is 30, 34. And then you have a 0 over here. That becomes 3,400. 3,400 minus 100 is equal to 3,300. And so you have 3,300, the square root of 3,300. Now this is your standard deviation. This is your standard deviation. Standard deviation. To calculate variance, which is equal to sigma squared, you have to write 1 divided by 5, the square root of 3,300, and square it, which is equal to 1 by 25 times 3,300. Now 3,300 divided by 25 is equal to 1 times 25 is equal to 25. 80. 3 times 25 is equal to 75, 50. 2 times 25 is equal to 50, 132. 132 is your variance. Sigma squared. So question number 8. Question number 8. Your x bar is equal to 27. X bar is equal to 27. And 132 is correct. Okay. So that is that. Question number 9. Question number 9 is, okay, Okay, so the next example that we have here is example number 9, which is basically you have some data here. Okay, so you have basically this data here. You have basically all of these heights in centimeter. Heights in centimeter, and you have basically the frequency related to them, number of kids, for example, or children, number of people, for example. So you have 70 to 75. You have 75 to 80. You have 80 to 85. You have 85 to 90. You have 90 to 95. You have 90 to 95. You have 95 to 100. 95 to 100. 100 to 105. 105 to 110. 110 to 150. 110 to 115. 3477. 3477. 15966. 15966 and 3. So you want to calculate the variance. You want to calculate the variance, mean variance and standard deviation of this data. So in order to do that, first, basically this is going to be your f of I. And you need to, of course, you need to know your x of I as well. So using the shortcut method, if you want to calculate this data, we said that basically x bar is equal to basically that was something like, not this one, physics, no, statistics, okay. We said that, I have this somewhere over here, I don't know what happened to that thing. Okay, so if you want to calculate x bar using the shortcut method as well, we said that x bar is equal to a plus h times y bar. So what we need to do is basically find our basically y of I. So in order to find y of I, first I need to find my x of I. So x of I here is equal to, is basically the average of the upper and lower limits of the class sizes here, which is, for example, 70 plus 75 is 145. 145 divided by 2 is 145 is 140 divided by 2 is equal to 70, and 5 is 2.5, so 72.5. 72.5. 75 plus 80 is equal to 155. 155 divided by 2 is 50. 25. 2.5 is 5, basically 7. 77.5. 77.5. And then if you add 5 to each of these, then you will get the next one. So for example, you can go for 77.5 plus 5 5 is equal to 82.5, 82.5, 87.5, 92.5, 97.5, 102.5, 107.5, 107.5, and 112.5. So these are the x of i's that we have. So we said that basically x of I or y of I is equal to basically x of I minus a divided by h. So I take, for example, some value like this as a. I take this as a. So then y of I, which is basically x of I minus a divided by h, is going to be this x of I minus this value divided by 5, which is the class size. So for example, 72.5 minus 92.5 is equal to 20. 20 divided by 5 is equal to 4. 77.5 minus 92.5 divided by 5 is what? Is 92.5. 77.5. So that's 0. That's 8. That's 12. 5. 1. That's 15. 15 divided by 5 is equal to 3. I think this gives us 4, 3, 2, 1, 0, and then 1, 2, 3, 4, something like that. Let's see if that's the case. Then the next one, you have 82.5 minus 92.5 divided by 5. So 92.5, of course these are all negative. These are all negative. 92.5 minus 82.5 is 10. 10 divided by 5 is equal to 2, but negative 2. Negative 2, negative 1, 0. And then when you get over here, 97.5, 95.5, 5 divided by 5 is equal to 1, 2, 3, and 4. So now the numbers get basically considerably small. There is nothing, now you can work with them pretty easily. Now you can find your y bar with, for example, if you want to find your y bar, since you know that basically x bar, for example, is equal to sigma f of I x of I divided by sigma f of I. So y bar would be the same, again, sigma f of I y of I over sigma f of I. So I need to calculate f of I y of I here. F of I y of I, which is equal to, this is f of I, this is y of I. That's negative 12. That's negative 12. That's negative 14. That's negative 7. That's 0. 9, 12, 18, and 12. And now if I want to calculate sigma f of I y of I, that's equal to negative 24, negative 24, and then over here you have negative 21, negative 21, that's negative 45, and then you have 20, 30, 42, 42 plus 9 is 51, is 51, 51 minus 45 is equal to 6. Let me use a calculator to check this because I don't want to. That's 12 plus 9 plus, sorry, minus 7 minus 14 minus 12 minus 12 is equal to 6. So sigma f of I y of I is equal to 6, and sigma f of I here is equal to 7 plus 7 is equal to 14, or 3 times 7 is equal to 21, 21 and 15. And then over here I have another 15 and another 9. So that's a 21 plus 30 plus 9, which is equal to 9, and then 59. 59. So that means that my y bar is equal to sigma alpha by y, which is equal to 6 divided by 59, which is equal to 59. Y divided by 6 divided by 59. Now, let's see what we can do with that. Now, since I have my y bar, now I can calculate my x bar. So x bar is equal to a plus h times y bar is equal to a, which is 92.5, plus h, which is 5, times 6 times 59. Now 59 is a number which is divisible by nothing as far as I know. 59 is, it's a prime number. It's a prime number, so that's 30 by 59, so that's 92.5 plus 30 by 59. That's it. We can calculate that. So 30 divided by 59, so 0, 0. And then if you add the 0 over here, 300, that's 6 times 5 times 6 is equal to 300. So 5 times 1 is equal to 45, 4, 25, 29. And you get a 5 over here. And you have over here again, if I add a 0, and a 0, a 0, 0, 609 times 59 is equal to, I think, 8 times 81. 5 times 1 is equal to 45. 45 plus 8 is equal to 53. 53, no. 531 is correct, but doesn't fit. So I think an 8 would be a good candidate. 8 times 9 is equal to 72, 7. 8 times 4 is equal to 40, 47, and then you get some remainder here. I'll take it as 0.51. Take this as 0.51. 30 by 59 is 0.50847. Okay. Take it as 0.51, and so you can add the two numbers together, 92.5, 0.51, and, well, you can write this 1, but it's really, you cannot really use it in your data because you don't have that much precision with this number. 1.393, I take it as 93. So your x bar is equal to 93. Now let me check with the answer here, and then if that's the correct answer, we will move. 93 is the mean of the data. So x bar is equal to 93. So now what we can do is calculate variance and standard deviation. Now, since we're using the shortcut method, it's important to note that in the shortcut method we have only these basically this formula, which is sigma is equal to h divided by n times the square root of n times sigma f of I y of I squared as I goes from 1 to n minus sigma of f of I y of I as I goes from 1 to n whole squared, that is an n, and take the square root of this whole thing, that is standard deviation. Standard deviation. Now to calculate deviance, I'm not sure if I'm using the right word here, variance, I'm sorry. To calculate variance, you need to take this sigma and raise it to the second power. Sigma squared is going to be your variance. So you can basically start with this formula and then square it to calculate variance as well, because it's basically, I mean, technically it's the base thing, only sigma raised to the second power. So what I'm going to do is basically, there is not much that I need to calculate here, because I've already calculated sigma f of I y of I here, and the only thing that I need to calculate is sigma f of I y of I squared, and that's all that we need to do here. So I'm going to take a screenshot here. This is sometimes okay. I'm sorry, I didn't actually mean to do that. But this drawing software is, oops, sorry. Okay, let me change my brush and then, great. This recording software is not very happy with my operating system, so now I'm going to erase all of this and just calculate f of I y of I squared. So f of I y of I squared, and so that is equal to this times this, so that's 16 times 3 is equal to 30, 18, 48. Over here 9 times 4, for example, is equal to 9 times 4 is equal to 9 times 4 is equal to 36. So 9 times 4 is equal to 36. Again, 4 times 7 is equal to 28. 1 times 7 is equal to 7. 0. And then you have 1 times 9 is equal to 9. And then you have 4 times 6 is equal to 24. 9 times 6 is equal to 54. And 16 times 3 is equal to 30 and 40, 18, 48. Now, what I need to do is basically calculate sigma f of I y of I squared, which is equal to all of these numbers added together, 2 times 48 is equal to okay, so let's see, that's 80, so let's see, it's 48, 36, 28, and you have 7 plus 9 is equal to 16, 24, 54 is 78, and 48. 1, 2, 3, 4, 32, 32 plus 12 is equal to 44, 8 plus 3 is equal to 11, 11 plus 2 is equal to 13, 14, 18, 18 plus 7 is equal to 25, 254. So now, if I have 48 plus 36 plus 28 plus 7 plus 9 plus 24 plus 54 plus 48 is equal to 254. Okay, so far so good. So then what we need to do is calculate standard deviation. So standard deviation, or sigma, is equal to, again, h divided by n times the square root of n times sigma f of I y of I squared as I goes from 1 to n, minus sigma f of I y of I as I goes from 1 to n whole squared. Take the square root of this. So, and this is standard. This is standard deviation. So h is equal to what? H is equal to the class size is equal to 5 here. So your class size is equal to 5. Your n is equal to sigma f of I. I don't know, I don't think we have, yes, sigma f of I is equal to 59 times the square root of this thing over here. N again is equal to 59 times sigma f of I y of I squared is equal to 254. 254 minus sigma f of I y of I is equal to 6 squared is equal to 36. And then if we calculate this, what we get is, well, let's calculate 254 times 59. 9 times 4 is equal to 36, 3, 45, 48, 4, 18, 22, 0, 22, 5 times 25, 27, 2, 5 times 12. And then you have 6, 8, 9, 4, and 1. So that's 14,986 minus 36 is equal to 0.5941. 14,950. That is the same thing as 5 over 59 times the square root of 14,950. Now this number, if you want to take the square root of that, so this is the value of your standard deviation, your variance is going to be, we will calculate this, but your variance is equal to sigma squared, which is equal to 5 to 59 times the square root of 14,950 all squared, which is equal to basically 25 to 59 squared divided times 14,950. Now we can calculate this one and then go back here and calculate that one. So 59 squared is equal to, 59 is a prime number if I'm not mistaken. 59 is a prime number. So you can leave it as it is. Maybe you can somehow simplify it with this thing over here. Now 14,950 divided by 2, you will get it's 14,000, 7,000. 900 is 450, 50 is 25, so you get 5, 7, 5, 7, 4, and 7. 7, 4, 7, 5. 7, 4, 7, 5. Now you can divide by 12, so if you want to know if this number is divisible by 3, for example, you can add all of the digits together. That's a 12. 12 plus 4 is equal to 16. 16 plus 7 is equal to 23, I suppose. 23 is not 11 plus 12 is equal to 23. So 23 is not divisible by 3. So this number is not divisible by 3. So then the next number would be 5. So 7475 divided by 5 will give you 1 times 5 is equal to 5, 24. 5 times 4 is equal to 20. 4, 7. 5 times 8 is equal to 40. 5 times 9 is equal to 45. 25. 5 times 1 is equal to 25. So that's 1495. There must be calculators that give you this factorization tree as well. So 1495, again you can divide by 5. 1495 divided by 5, you will get 2 times 5 is equal to 10. 4, 9. 7 times 8 times 9 times 45. 45 and 9. So that's 299. 5 times 299. And 299 is 1820. It's probably a prime number. 299 is probably a prime. Now it's 13 times 23. Okay, so it's 13 times 23. Now, in order to just practice for 13, for example, and 23, I suppose, is of course a prime number. 23 is actually a prime number. And of course, 13 is a prime number as well, right? So in order to calculate to see if this number is divisible by 13, the test is basically this. You need to know all of this. So you can do anything in mathematics. These are the basics. So you add 4 times the last digit to the remaining leading truncated number. Add 4 times the last digit. So truncate the number 29 and add 4 times the last digit. So that means that 4 times 9 is equal to 36. Add 36 to the truncated number, you'll get 5 and 65. Of course, 65 is divisible by 13. So 299 is divisible by 13. If you divide, you will get 23. That means that this is 13 times 23. And so that means that you can write this number as, and 59 was a prime number, right? So that means that none of these factors, 23 or 13 or 5 or 5 or 2, can be simplified with this 59. So you have to just do the calculation anyway, meaning that multiply this by this and then divide by this and you'll get the answer. So I'll do the calculation simply. That means that 59 squared is what is 59 times 59? That's 81. 8. 5 times 9 is equal to 45. 45 plus 8 is equal to 53. 53 is 0. 5 times 9 is equal to 45. 4, 25, and 29. And you have 1, 8, 14, and 3, 4, 8, 1. 3, 4, 8, 1. So this number becomes 25 times 14,950 divided by 3,481. Next, you need to basically multiply these two numbers. So 1495 times 25, and you have 0 there as well. So it's 25, 2, 45, 47, 4, 20, 24, 2, and 5, 7. A 0, and then 2 times 5 is equal to 10, 1. 2 times 18, 19, 1. 4. 2 times 1 is equal to 2 times 4 is equal to 8, 9, and 2. 5, 7, 9 plus 4 is equal to 13, 1, 16, 17, 1, and 3. And you have a 0 there as well. That's your number. That is basically this product. And then you want to divide it by 3481. So 373750 divide by 3481. You will get 1 times 3,481. So you get 6, and let's make this a 6, make this 13. So 13 minus 8 is equal to 5. 5 plus 8 is equal to 13, right? 5 plus 8 is equal to 13. And 6, that's a 2, 256, 0. And no, there is no 0 there. Okay, sorry, made a mistake here. Okay, so you have basically a 5 there. 2565, so you get a 0 there. And bring down your 0. 25,650. So that's around 3,500. And that's 25,000. So 10 times 3,500 is 35,000. 7 times 3,500 is 3,500 times 7 is, that's 21,000, and that's 3,500. That's 24,500. That's around 24,500. That must work. So I get basically 3,481 times 7. So 7 times 8 is equal to 56, 5. 7 times 1 is equal to 28. 28 plus 5 is equal to 33, 3. 21 plus 3 is equal to 24. 24,300 to 367. So it goes 7 here. So 24,367, and so you can go 4, 5, 14, 10, 3, 8, 2, 1, and then you can still continue here, meaning that you can add a 0 here, a 0 here, 12,830, and then probably that's around 3,500. So for 3 times, probably 3,481. 3 times would be 3. 3 times it's good to 24, 2. 12, 14, 1. 9, 10. That's 10,443. That's you cannot go any higher than that. So 3 times that would be 10,443. You get some remainder there, and that's I take it as 107.3, for example. I don't want to go any further than that. So your variance is equal to 107.3. Now the next thing that you need to calculate is standard deviation. So your standard deviation is this part. So this is your standard deviation, which is basically you're looking for this thing over here. This is your variance. Now for your standard deviation, so what you want to do is 5 to 59 square root of 14,950. So 14,950, take the square root of that. You want to basically, you want to group your numbers from the ones place in digits of basically 2 digits and 2 digits, and you will get basically something like this. Now 1 times 1 is equal to 1. If you subtract, you will get a 0, and then you have a 49 here. 7 times 7 is equal to, okay, sorry, I need to bring my down, bring the 1 here. 1 plus 1 is equal to 2. You have 1 digit here, 1 digit here, and so you have, for example, 21 times 1 is equal to 21. 22 times 2 is equal to 44. That's the one. So 22. So 2 times 20 is equal to 2 is equal to 44. 5 remainder. 550. Bring it down. And 22, you have 22, add a 2 to it, you'll get 24. 1 more digit here, 1 more digit here. And for example, 240 times 2, for example, 242 times 2, that's 484. That's what you can do. So a 2 here, 484. And you get a 4 here, 14, 10, 6, 6, 0. Put 2 zeros here and bring them down, right? And you can write your 242, add 2 to it, you'll get 244. 244, and 1 more digit here, and 1 more digit here, and you're looking for 244 and 1 more digit here times the same digit here. It has to be around 6,600. So that would be 2,500. 3 times 2,500 is 7,000. That's 2,500 times 3 is equal to, well, 7,500, so that's a 2 again. So 2 times 2 is equal to 4,884. So that's a 2 here, and you get basically 4,884. 4,884. And you will get some remainder here, but this part over here is approximately 122.2. So 5/59 times 122.2 is equal to, now this whole video we were just calculating numbers, which is okay. I mean, there is nothing wrong with that. So 122.2 times 5, 122.2 times 5 with with a decimal point. With decimal point, you'll get 5 times 2 is equal to 10, 1, 5 times 2 is equal to 10, 11, 1, 2, 10, 5 times 2, 10, 11, 1, and 5, 6, 611 divided by, that is the same thing as 611 divided by 59. 611 divided by 59. 1 times 59 is equal to 59, 21, and 21 0.0 over here, so 3 times 6 is equal to 180, so 177, I suppose. 59 times 3 is equal to something around 177. 3 times 1 is equal to 27, 2, 15, 17, 177. So 177, let's say it's 180, so 180, that's 33 remainder. So that is something about 10.3. Something about 10.3. And so that's basically your standard deviation. Your standard deviation is something about 10.3. That is your standard deviation. So as you can see, your variance, which is sigma squared, of course, is a greater value than your deviation, which is basically 10.3. Here that's 107, and the mean of the data was 93. X bar was equal to 93, and this was question number 9. This was question number 9. 93 is correct. 105.52, well, kind of. And then the other value was 10.3, I suppose. They are gotten as 10.27. Now all of this is, well, of course, interesting and nice, but you also need to understand what this data, what these answers actually mean. So I got my variance sigma squared is 107.3. Sigma squared is equal to 107.3. Sigma, I got it as basically 10.3, and X bar, I got it as 93, I suppose. Okay, so what we have here is basically, you see that basically these are the heights of these people. It goes from 70 all the way to 115 in centimeters. So the average of these heights was 93. So that means that on average, every one of these people was about 93 centimeters. Their height was 93 centimeters on average. And then these are basically two measures of what do you call it? How the data is scattered, or and of course you know that basically now, apart from this formula that you wouldn't understand by looking at it, we have another formula that we can actually use in order to understand these in order to understand these numbers. So on this one, okay, so the variance, so this value over here, sigma squared, is called the variance. Now the actual formula that we used for variance was sigma squared is equal to 1 over n, or let me write it this way, is equal to basically sigma f of I times x of I minus x bar whole squared over sigma f of I, as basically I goes from 1 to n, as I goes from 1 to n. So what that means is that this variance, that is basically the distance of basically each and every one of your observations x of i's from the x bar, which happens in this case to be basically 93, and we have basically we have raised each of those numbers to the second power multiplied by f of I, which is the frequency of each of those observations, and then we have added all of those numbers together. Once we have added all of those numbers together, then we have divided that by the whole number of observations, which happens to be, for example, 59 here, to take the mean of that. Okay, so what that means is that the square of the distances of each of those observations, when I'm saying each of those observations, I'm taking f of I into consideration, because f of I is multiplied by each of those observations. So when you say each of those observations, you're actually taking into account your f of I, right? Now the square of the distances of each of those observations from the mean of the data, if you add all of those numbers, if you add all of those numbers together, and then divide that number by the total number of observations, meaning that you had, let me erase all of this, we don't need them anymore, meaning that you had basically all of your observations were basically, let's say that these are all of your observations go from, for example, 70 to 115. So 70, for example, 75, 80, 85, 90, 95, 100, 105, 110, and we have basically 70, 75, 80, 85, 90, 95, 100, 105, 110, 115. So these are all of your observations. This is the minimum of your observation as far as these classes are concerned. Or you can take even these numbers over here, which go from, for example, 72 to basically 212. Let's take those numbers. So we have all of these observations here, which go from 72.5 all the way up to 112.5. The mean of all of these observations was 92.5. Let's say that this is 92.5. Now we had all of these observations over here, right? We had all of these observations over here, and what we have done is that we have taken we have taken basically each of those observations. We have taken each of these observations, and for example, in the case of this observation, we have taken the distance of the observation from the mean. And that distance I have squared it. Okay. Again, for example, there was some observation over here. I have taken the distance of that observation and squared it. And now I get basically some number of such distances over here. I have added all of those numbers together and then divided that number by the total number of observations. That means that, for example, that's actually the mean. That is the average. That this if I want to just use simple English to express what this formula is, that is the average of the square of the distances of each of the observations from the mean. So this formula, whatever that is, it is the average of the square of the distances of each observation, the average of the square of the distances of each of the observations from the mean. That's basically what this is. Okay. So that's basically how you're supposed to understand, for example, this number. This number is the average of the square of the distances of each of the observations from the mean. And then sigma, basically, this is sigma squared. And if you take the square root of that, that number is called basically standard deviation. That number is called standard deviation. That's basically the whole idea over here. So now if that's basically all that it is. So now we have one more exercise left here, which is exercise number 10. And we will do that in the next video. I'll see you in the next video.